Assalamualaikum and a very good day to everyone. So today we will continue our next topic in chapter 2, which is regarding on the Laplace transform properties. So here is the outline. Okay, so we have covered the introduction, definition, and also inverse Laplace transform in our previous lecture. So therefore, today we will cover about the properties of the Laplace transform. Now let's look what are the properties of the Laplace transform. So the properties of the Laplace transform is similar with what we have covered or learned during in chapter 3, okay, which is same with Fourier transform. Okay, for example, linear operation, differentiation, integration, time shifting, frequency shifting, convolution, and modulation. So all of this you guys has actually familiar when we discuss Fourier transform. Okay, now let's look at the first properties, which is the linear operation. So if let's say you have a two different time domain function and each of them have a different value of constant, so when you want to convert it into Laplace transform, meaning that you want to change from the time domain into a S domain, okay, the the value of the constant here will remain the same, and this is actually proven by this solution here. Okay, so this solution here is to prove that the constant is remain the same when you change from the time domain into S domain. Let's look some example for the linear operation. So given f1t, the equation is cos at cos at, where this cos at can also be written as such. Yeah, so this equation, if we can rewrite it into a normal representation, okay, it can also be rewrite as such. Okay, and we need to find, the question asks us to find the Laplace transform for this equation. So meaning that our objective now, we want to have the equation in S domain. Yeah, in S domain. So what we need to do first is, okay, we need to rewrite this equation to make it more simpler, right? So that we can identify it more simpler. So this equation can be separated into these two equation here. So 1/2 is gonna be the constant. Okay, 1/2 is gonna be the constant, and we can see that the exponential one will gonna be the positive and one will gonna be the negative. Okay, so this is the T domain. Okay, this is the equation that we have rewrite into a simpler form in a time domain. So we need to convert from the time domain into S domain. So what we have to do first is we need to refer to the table, to the appendix. Okay, so make sure that you are referring to the table that is regarding on the Laplace, yeah, Laplace transform. Okay, so always remember the Laplace transform is always in a S domain. Yeah, so if we look at the appendix, okay, if we look at the table, the similar, okay, the similar equation with the equation that we want to calculate is this row. Okay, is this row. So exponential negative at ut can be converted into S domain. It will become 1/s plus a. Okay, so therefore we can convert this. 1/2 will gonna remain our constant. Okay, so it will not involve into the Laplace operation. Okay, so the Laplace for exponential at. Okay, so please pay attention here. There is a negative here, right? There is a negative here, so therefore how to become is positive, meaning that it must be negative 80. Okay. So therefore the value of a here we're gonna be negative a. So it can be rewrite as such, and this one it can be rewrite as such. So from this equation you can expand and you can simplify it to become this. So therefore this will gonna become your final answer. Right, now let's look another example for linear operation. So here it's given to us the equation in S domain. So it is 3 over s squared minus 4s plus 3. Okay, and we need to find the inverse Laplace transform, meaning that our objective now, we need to find the time domain. Yeah, so it is an inverse Laplace. So what we have to do, okay, the equation, it's written and it's given as such. Okay, what we need to do is we need to apply the partial fraction. Okay, so I believe all of you guys has familiar with this partial fraction. Okay, partial fraction in Fourier transform chapter. Okay, so what we need to do is we need to factorize the denominator part. Okay, so the factorization will give us s plus 3 and s plus 1. And it's going to be a and b, and we need to determine the value of a and the value of b. Okay, so you also can use the partial fraction as I mentioned before. You can also use your calculator, yeah, to obtain the partial fraction of the which is the value of a and the value of b. So you will obtain, okay, from your calculation you should obtain the value of a is equals to 3 over 2 and the value of b is negative 3 over 2. Alright, and we can replace back the value of a and b in the equation given, and we will get as such, right? So what we need to do next is we need, in order to obtain the the equation in time domain, we need to refer to the table. Okay, so now the table, you need to refer at the S domain, look and find which is the similar with the one that is we have obtained earlier. So based on the table, we can see that this row is the similar with what we have obtained. Yeah, so therefore the inverse of this equation, okay, the inverse for this equation, it will gonna be 3 over 2 exponential 3t minus 3 over 2 exponential t. Okay, right? Okay, now let's look another operation, which is the time shifting operation. So let's recall what we have learned before. So time shifting is anything that the operation is inside the bracket, you're gonna be time-based operation, right? So in this case, the time minus a, okay, t minus a, so meaning that the time, okay, is shifted as a. So in S domain, how it gonna be rewrite? It gonna be, so since that the time is shifted as a, so it gonna be exponential negative how much the time is shifted. Yeah, since that the shifted as a, so therefore a s, yeah, and fs, right? So now let's look at the example here. So the example said find the Laplace transform for this impulse, and given that from 0 until c, okay, the time range from 0 until c, the value is 1, and otherwise it is 0. So if we can plot a graph, okay, so this is the time graph, so this is the ft, and the value here is 1. Okay, so from 0 until c, okay, the value is of the value for the y-axis is 1. All right, and otherwise they mention as 0, so meaning that otherwise it's gonna be 0. Yeah, otherwise it is 0. So sorry, so if we can write or come out the equation for this ft, so we can see that the graph is start from 0, so it is going up, and it is end at c, so therefore it's going down at c. So if we can write the equation, it's gonna be ut, right? Ut for this equation, and for this one, it's gonna be negative since that it is going down, ut minus c, right? ut minus c. So therefore, the equation for ft is given as ut minus c. And the question asks us to find the Laplace transform, meaning that we need to find the fs domain. All right, so we can separate the equation that we have obtained earlier into ut and another one ut minus c. So ut based on the table, we will obtain the s domain is going to be 1 over s. However, ut minus c, since that it is shifted as c, and based on the upper here, uh, how much that the time is shifted is going to be written as exponential negative how much the time is shifted into s domain, right? So now it is shifted as c, so therefore exponential negative c, since that it is shifted as c, 1 over s. So from this equation we can simplify and it will become as such, right? Alright, now let's look at another example. So in this example, they provide to us the equation in S domain, and we need to find the inverse Laplace for this equation. So meaning that we need to obtain the value of time domain. Alright, so we can rewrite this equation to be, okay, to 1 over s squared minus 2 exponential negative 2s 1 over s squared. All right. So if we look at the table, okay, 1 over s squared actually, okay, 1 over s squared actually, it is similar, okay, it is similar, or it can, it will gonna be tn ut, where in S domain it will gonna be n factorial s plus n plus 1. Alright, so in this case, since that the value of s is s squared, therefore the value of n we can determine it is equals to 1, right? So therefore for this part, okay, so therefore for this part it's gonna be in S domain it's gonna be 2 t n is equals to 1 ut. Alright, so now left behind is only this part, so we can see 1 over s squared is same with this 1 over s squared. However, there is exponential negative 2s, right? So therefore we know something that is time shifting is involved because there is an exponential here. So therefore, okay, therefore we can rewrite this equation to be, so how much the time is shifted? The time is shifted. What is the value of A? A is equals to 2, right? A is equals to 2. So therefore, for this equation, for this behind equation, yeah, it will become t minus 2, okay, ut minus 2. All right. So don't forget the 2 in front here. So therefore, if we can combine both of those, it will become the inverse Laplace of it, it will become Fs is equals to Ft. So therefore, it will become 2t ut minus 2t minus 2 ut minus 2. Alright? So please, this correction, sorry, the answer provided here is a little bit different. So this is the correct answer. Yeah? Okay, so now let's look for the another operation, which is time scaling. So let's see, in a time domain, the time is scaled up as a. So in a s domain, okay, it gonna be the amplitude will be divided as a, and also at inside the bracket, the s will be divided as a. All right. So now let's have for a time transformation where it has a time scaling and also time shifted on the same time. So the Laplace of it is going to be, the amplitude will going to be divided as A, and also inside the bracket it also going to be divided as A, same as above here, for because it is time scaling. And don't forget, since that there is a time shifted as a t naught, therefore they're going to be exponential negative as t naught, okay, and the t naught is also will gonna be divided by a. All right, So if there is a combinations of time scaling and time shifting, okay, everything must be divided with the value of how much the time is scaled up. Yeah, okay, the amplitude is divided by A, the S also going to be divided by A, the exponential for the time shifted is also going to be divided by A. So now let's look into the next operation, which is the frequency shifting. So for the frequency shifting, you can see here in this equation, the frequency now is shifted as A. So in the S domain, okay, it also will gonna be shifted as A. So you can see the exercise given here, and where it's provide to you the S domain equation, and you need to find the YT. So meaning that what you need to do is you need to do the inverse Laplace, right? So from here, I think you should know already. You need to apply a partial fraction, and you compare with the table, okay, and you will get your answer as such, right? So please try this. Yeah. Okay, let's look another operation, which is convolution. So they ask if Hs equals to Fs Gs, then the inverse Laplace transform of Hs is a convolution between the Ft signal and the Gt signal. So we have learned, we have familiar the convolution, the convolution of two signal. For example, in this case, Ht, if which is the product of both signal Ft with Gt. So in order to solve this equation, we can convert it into S domain, because in S domain, convolution will become multiplication, right? So for example, in this exercise, find the convolution of the signal xt with itself. Okay, so what are the question asked actually? So xt is convolved with itself, meaning that xt is convolved with xt. So how to solve this? uh, we know, let's say the convolution of xt with xt is equals to ht. So in S domain, we can rewrite it to be hs is actually xs multiplied with xs, right? So xs, we know the equation is given as such, yeah? So xs, what is the value of xs? So the value of xs, ut is equals to 1 over s, right? And negative ut minus 1, since that it is a time shifted, so it's going to be 1 over s, but then there must be an exponential, it's shifted as 1 negative s, right? So the convolution of this, so therefore this will going to be multiplied, xs will going to be multiplied with another of this. So therefore I don't have any space to write. I try to use another color so that we know. I use this area, yeah. Hs is equals to 1 over s minus 1 over s exponential negative s multiply with 1 over s minus 1 over s exponential negative s. So if you solve this, okay, if you solve this, you will get 1 over s squared minus 2 exponential negative s over s squared plus exponential negative 2s over s squared, right? And this is the value of hs. But now since they want the convolution of this, yeah. So therefore, we need our answer should be in ht. Should be in ht. Yeah, should be in a small letter, not capital letter. Should be in ht. So we have already obtained the hs. So what we need to do? We need to do the inverse of this equation here. So ht will equals to Laplace or inverse Laplace of this 1 over s squared minus inverse Laplace of 2 exponential negative s over s squared plus inverse Laplace exponential negative 2s over s squared. Okay, so this inverse you will get or you will obtain this answer. Yeah, you will obtain t ut, which is referring to this one, and this one will gonna be negative 2t minus 1 minus u, there's no minus here, yeah, u t minus 1, okay, and plus t minus 2, t minus 2, okay, t minus 2, and u t minus 2. Alright, so you will get this answer. And if you can plot the graph of the convolution, you will get as such. The graph we're going to look as such here. Okay, let's look at the another operation, which is differentiation operation. For example, it's given your t time domain equation, and it is in in a differentiation form. Yeah. And you need to determine the Laplace transform of that equation. So it can be written as SFS minus F0. So this F0 means that when the time is equals to 0, or in other words, it is also known as initial condition value. Okay, so this initial condition value here is proven by this equation. So you can try to prove this by yourself. Okay, but now let's go to the next slide to see what if the differential is in a higher order, where 2 times differentiation or 3 times differentiation. Yeah. Alright, so now let's look for the higher order differential form. Right, so let's see when there is a 2 order of differential. Yeah, so for 2 order of differential can also be written as such here in time domain. Okay, so therefore in s domain it can be written as s squared fs minus f, the 2 here we're going to be minus 1, so therefore it will become 1 f0 minus s0 f prime. So this is f, so here we're going to be f prime. Yeah. Okay, so s0 here meaning that it is actually equals to 1. Yeah, so therefore it can be written as s squared fs minus s f0 minus f prime 0. Okay, so this is for the 2 order. How about 3 order? Okay, so in this case 3 order, yeah, 3 order, sorry, 3 order, yeah, 3 order t, so therefore you're gonna start with s3. Okay, fs still the same, minus s3 minus 1, it's gonna become 2 f0. Okay, and then minus 2 minus 1, it can become 1. So since that this is already f, here we're going to be f prime 0, and then minus s0 f double prime 0. Okay, so from here, so this is actually equals to 1, so therefore it also can be written as s3 fs minus s2 f0 minus s f prime 0 minus f double prime 0. Okay, so therefore if you increase the differential order to, let's say, n, yeah, so therefore the first one it will become Sn Fs, how many order that it is referring to. And the second one we're going to be n minus to 1, and you can stop until your S is no longer appear in the term. Alright? Right, let's look at the example here. So there is given xt, okay, x double prime t plus 3x prime t plus 2xt equals to 0. Okay, so when it is equals to 0, meaning that this is a homogeneous, right? Okay, we already discussed this in our previous lecture. Yeah, so this is the homogeneous equation, and we need to find the xt if x 0 is equals to 1 and x prime 0 is equals to -4. So what should we do is we need to change into Laplace first, and then since that they asked us to find the value of xt, so at the final what we need to do is we need to convert um, into inverse Laplace to get or to obtain the value of xt, right? Okay, so now let's try to solve this equation. Okay, so this is, let's separate the equation first. So this is the first one, this is the first term, this is the second term, and this is the third term. Okay, let's do one by one. Yeah, so for the first one, it's gonna be, it can be written as s squared, okay, xs, since that our equation is in x, so therefore x here, minus sx, sorry, yeah, so supposedly this should be small letter, right? x0 minus x prime 0, right? So this is for the first term. Okay, so this is for the first term, plus, okay, plus 3 we bring it in front. The second term, it is as, it is only one order of differentiation, right? As xs minus x0. Okay, so this is for the second term, plus 2, okay, this is for the third term, yeah, 2xt, therefore it's gonna be xs. Okay, this is for the third term. Okay, third term. So now let's substitute with the value they already mentioned. The value of x naught, sorry, the value of x0 is equals to 1, and the value of x prime 0 is equals to -4. So therefore this value is equals to 1 and this value is equals to -4. Okay, this value is equals to 1, and yeah, all right. So therefore, once we have substitute, we will obtain as such, right? We can substitute inside that, and we can simplify, and we will obtain as such. And from here, we can factorize the xs, alright? The xs, okay, it will gonna be as such. And therefore, we can bring, since that we need to determine xt, okay, we need to determine the xt, we need to find the value of xs first. So we need to bring it on this side, okay, so it will become s minus 1 over s squared plus 3s plus 2, right? And from here, what we need to do, as usual, we need to use our partial fraction, and we will get the value is as such. And from here, this is the value of xs, then only we can determine the value of we can determine the value of xt. So therefore, your xt is going to be 3 exponential negative 2t minus 2 negative exponential negative t. Alright? Okay, now let's look another example. So in previous example, it is in homogeneous, but since that it is equals to 0, but in this example, it is not equals to 0, therefore it is inhomogeneous, right? Okay, it is in a homogeneous equation. All right, so given y double prime t plus 2y prime t plus yt is equals to 2, where y 0 is equals to 3 and y double prime 0 is y prime 0 equals to 2. And we need to determine the value of yt. So same as before, yeah, we need to do one by one here. Okay, so this is the first term, this is the second term, and this is the third term. All right, so now let's try to do, so y double prime t, I'm not right again the questions, yeah. Okay, so for the first term it's going to be double prime, right? So therefore it is s squared ys plus minus sy0 minus y prime 0, right? So this is for the first one, this is for the first term, plus 2 for the second term. So therefore it's going to be sys minus y 0. Okay, so this is for the second term. And for the last one, yeah, plus ys, yeah. So this is for the third term, and equals to 2, so 2 in, if we convert into S domain, it will become 2 over S. All right, so I believe you, please, you are able to solve this equation. Okay, please try to solve this. Okay, I will left to you to solve this. Okay, so sy, you just need to replace the value of this is equals to 3, the value of this is equals to 2. Okay, this is equals to, sorry, this is equals to 3, right? So therefore it will become minus 3s minus 2 plus 2sys, okay, minus 6 plus ys equals to 2 over s. Okay, so you can try to simplify and you should obtain your ys equals to something, and then you need to do the inverse Laplace of this, so that the inverse Laplace of ys, then you will obtain of yt, and that's going to be the answer. So the answer here, please make correction, this is the wrong answer. Okay, the answer that you should obtain is equals to yt is equals to 2 plus exponential negative t plus 3t exponential negative t. Okay, so this is the correct answer that you should obtain. All right. Right, the next operation is the integration. Okay, the next properties is related to integration. So it's given that you need to find, so this is the equation of a time domain where it is an integration and you need to do the Laplace. All right, you need to obtain the Laplace. So for the integration in S domain, okay, the equation should be fs. Okay, the equation in S domain, you should divide with the value of s. Okay, with the value of s inside the bracket, you should divide, yeah, with the value of s, right? Next, for complex frequency shifting, so it is much or less similar with the frequency shift property that we have looked just now, okay, in our previous, a few previous back slide, yeah. So let's, for example, you have this equation, yeah, which is the ft is equals to ut minus c. So we know that there is an involvement of time shifting and there is also a frequency shift, yeah. So meaning that this is a complex equation. So if we can rewrite this equation, it's going to be ut exponential at minus ut minus c exponential at. So therefore from here we know, okay, this will, as a result, this is the result from here, it's going to be 1 over s minus a, and from here this will going to become negative exponential c, because the time shifted as c, s minus a over S minus AN. From here, we can rewrite the equation to become as such, right? And for the modulation, okay, modulation much or less same as Fourier transform that we have learned before in previous. So for sine, it's gonna look as such, okay, in S domain, in S domain, yeah, in S domain. And for cosine, it will gonna look as such in S domain. Okay, the only difference is for sine, it's gonna be negative, for cos, it's gonna be plus, right? The rest of these notes that I shown here, yeah, from slide number 19 until slide number 24, this is the notes for a partial fraction for those who are still not really good in a partial fraction. Okay, so this is a notes for the partial fraction that you can refer. So there are a few sources, okay, when the source is real and not similar, real and similar, and another one is complex. So I will leave this to you for you to learn it by yourself, because some students, yeah, they use their own calculator to solve the partial fraction operation. Okay, so for those who don't want to use your calculator, you can refer to this slide in order for you to solve the partial fraction operation. Okay, but I will suggest you to use your calculator for your, I mean, for time, for the time, for to save time. All right. So I think that's all by now. Thank you. I will provide some exercise in our next class after we discuss about the circuit analysis. All right. Thank you so much.